Okay, in this second part of the seminar, we are going to explore supervised classification models. Well, now, instead of predicting values, what we are going to do is to predict categories, okay, to predict a variables from a set of variables. Let's load the libraries needed for this practice. And now we are going to use a new dataset, which is called a SRI thermal comfort dataset. Here we will have around 40,000 rows of value from people who were put in an environment in different locations around the world and asked how they felt in terms of thermal comfort. Basically, this is a survey to measure the thermal comfort in the working environment, so mainly in offices. So let's load the data set and let's explore what we have here. So you can see that we have uh, different columns with year, season, climate, building type, country, city, and some weather conditions. And finally here we have this column, which is the thermal sensation rounded, which is the variable that is going to tell us the thermal comfort. Well, if we explore the info, here you can see that we have more than 40,000 rows and that we have in total 16 columns. Okay. Also, you can see here the type of variables. We have some numericals, but also we have some objects. And here we can select thermal sensation, which is the variable that we are to predict based on the other features, okay, in the rest of features. So this variable, thermal sensation rounded, can take 7 different values from -3 to +3, including 0. And basically it means that if the person is comfortable, the value will be 0, while positive values represent being hot or too hot, and negative values represent being cold or too cold. So we understand now the data set and what we want to do. So basically we are going to use the rest of variables to predict thermal sensation as a classification objective. And to do that, we are going to use random forest classification model. Random forest is a form of decision tree model. Here you have a link to learn a little bit more about decision tree model, but basically here you have a graphical representation of decision tree. Good thing of random forest is that this is a multi-purpose model and it's quite good as the first model to apply to more complex data sets. Mainly because this model will help us to understand pretty well which are the most important features and what is a kind of baseline accuracy for a machine learning model. So to apply that model, the first thing that we have to do is to create the feature dataset. So this is our initial dataset. We have all this column, as we said, and we are going to use columns as feature in the model to predict the last column, which is the thermal sensation rounded. So you can see that some of the features will be related to the building context, the city, the country, other are connected with the environmental conditions, and other are just personal factors such as genders, such as clothes that the person were wearing, etc. So now we are creating the feature columns and the variable that we call feature. So here you have the info. So from the 16 columns, we are selecting here the feature columns, which are 13 because we are not including publication, because this is connected with our research study. We are obviously not including thermal sensation around it because it is actually our target variable, but also we are not including thermal sensation, which is obviously connected with our target. So here defining the features. Now you can see the info for the features. We have 13 columns, but still, as I said, some of the data types are objects. And then we will define the target variable. As I said, we have 7 different categories from -3 to +3. As I say, we have still some categorical variables that we need to transform into dummy variables in order that they can be used as input for the model. So again, we are going to use this function for pandas get dummies, and we are transforming the categorical variables into dummy variables. What does it mean? For example, here we have season winter or city Chennai or country India. When we are creating the dummy, for example, for season, we need now 4 columns. Okay, autumn, spring, summer. Same for climate, same for cities, for countries. Okay, so now instead of 13 columns, we actually have 102 columns. Now we're going to create the train and test data sets. And now we can do it automatically. In the last example, in the regression example, we did it manually because we wanted to train the model past data to predict future data. So the order was important. But in classification, it doesn't matter because each of the rows is going to be a self-contained sample that is used to train the model. So what we are going to define here is that we split the dataset into 70% for training and 30% for test. And now we have the features train, which is the 70% of the whole data. You have here the information. And the feature test, which is here the 30%. Okay, you can see that here we have a considerable higher number of entries. What we are going to do now is to call the random forest model and specify various input features that influence the way the model is constructed. Actually, these parameters can be optimized in order to achieve a better accuracy. To optimize the model, it's important to understand how to tune the hyperparameters of the machine learning models in order to reduce the error metric. But obviously, this is quite complex, and here we are just scratching the surface of machine learning. So we are running the model. Now we are going to use ArrowBag, which is a tool for determining the error calculation. So this will give us the accuracy of our model. Our accuracy is, as you can see, 0.487. It's around 49% of accuracy. Apparently this is not too much, but considering that we have 7 different groups, this is not such bad. A way to understand how good or bad was our model, we can compare our model with a baseline accuracy created just by random guessing. So the baseline model by random guessing is only 28%. So our model is almost twice. So it's not so bad. Finally, I want to show you a tool in order that you can understand how well a model performs as compared to the data in which we know the closest. So classification is often evaluated by more than just accuracy. So here you have that we can check the precision, recall, F1 score, or support. You have here the meaning of each one. Other important characteristic of random forest is that we can calculate the feature importance. It means we can understand which features contribute the most to accurate predictions. So in our model we have 102 features and we can rank them depending on how important is their contribution to the accuracy. As you can see, the features that contribute the most for accuracy are the ones connected with weather conditions. Also, we can plot the feature importance, and this is also very interesting. We can create confusion matrix, which is a visualization that helps us to understand which clauses are being misclassified and which one are being more accurately identified. So we can define this function and compute the confusion matrix. So here you can see how many observations for thermal control were accurately predicted. It means, for example, how many observations with value 1 for thermal comfort were actually predicted as 1. It means it was accurate. And for example, in that case, we can see that there were a higher number of ones predicted as 0 than as proper 1. What we want to focus in a confusion matrix is the diagonal, which represents which one have been accurately predicted. We can normalize the confusion matrix in order to visualize better the accuracy of the model for each category. Here you can see a little bit better this diagonal, but however we can observe that our model has a tendency to predict different categories as 0. This is pretty connected with the number of 0 samples that we had in our training data. So that in order to do this model better, we probably need additional data that give us better information when people are too hot or too cold. Because in that case, we have a lot of people that are saying that they feel comfortable when, according to that model, they should feel too hot or too cold. Also, since these data sets come from different locations, maybe there are some cultural bias there, and it would be a better idea to create prediction models for every location. Okay, this is all for that session. Thank you so much for your attention, and we keep in touch. Goodbye.